As we've seen, a histogram is a type of bar chart, and bar charts are pictures of a data set that help us to see the data's important characteristics. A data set is a group of bits of information about a single topic, quite literally about anything you can imagine. One data set could represent the finishing times of runners in a marathon, like 4 hours, 45 minutes, and 23 seconds, and 5 hours, 4 minutes, and 19 seconds. Another data set could represent how common certain types of gardens are along the course of the marathon, like 14 rock gardens, 62 vegetable gardens, and 18 flower gardens. Another data set could represent the numbers of vegetable plants growing in a garden, like 6 carrot plants, 5 pumpkins, 12 vine tomatoes, and so on. Still, another data set might represent the number of edible tomatoes growing on tomato plants that are harvested, like 6, 10, 7, 4, and so on. The first important thing to remember when considering the use of a histogram is the kind of data set you are dealing with. Only certain data sets can be represented in a histogram. Of the 4 examples discussed earlier, only the marathon times and the number of edible tomatoes per plant could be represented in a histogram. The types of gardens and types of vegetable plants could not. Let's look at tables for the data sets and see if we can uncover the differences that make some work with a histogram and others not. By comparing the data sets on the left and right, what differences do you notice? For starters, you might notice that all pieces of data on the left are numerical, while all the pieces of data on the right are not. Instead, the data sets on the right are nominal, which means the pieces of data are essentially names or types of things. It's true that histograms are made only from numerical data sets, but there's even more to it than that. Notice how the marathon times data set is presented in an order from shortest time to longest time. If we want to resort the edible tomatoes data set, it could be represented in an order from least to most edible on a single plant. A data set with this characteristic is called ordinal, because the pieces of data can be represented in a numerical order from smallest to largest. Histograms are made from the ordinal data sets. Note that the data sets on the right could also be resorted into an order such as alphabetical, but since they are not numerical data sets, we wouldn't call them ordinal, and we still wouldn't represent them with a histogram. Another difference in these data sets is how the pieces of data could be grouped in each. If we were dealing with hundreds of pieces of data in the marathon times data set, instead of only the 15 that are included, we would want to break the hundreds of times down into categories, containing a number of pieces of data in each. For instance, we could break the marathon times pieces down into the categories of 4 to 5 hours, 5 to 6 hours, 6 to 7 hours, 7 to 8 hours, and so on. Notice how it is set up this way in the following data set for the moviegoers' ages at a theater. The categories in the left column are in order from smallest to largest, but they are made up of smaller groupings of numbers from smallest to largest. These categories are called intervals, and they designate a data set that can be represented with a histogram. Think how difficult it would be to categorize the nominal data sets in these intervals. Since there is no real increasing order from smallest to largest for rock or sculpture or pumpkin or tomato, it wouldn't make much sense to make intervals of rock garden to sculpture garden and flower garden to vegetable garden any more than it would make sense to create intervals of carrots to peas and tomatoes to beans and so on. So in short, we use histograms to represent data that is numerical, ordinal, and possibly categorized by intervals. If those 3 things aren't true for a data set, we won't be able to use a histogram to represent them. One final important note before you test your understanding of which data sets can be represented in a histogram. It is possible for a data set to be numerical but still not work. An example would be when data preparers use a number to represent a particular category, like at a Halloween party, where costume types might be lumped together into categories of horror, superhero, or comedy, and then those categories are given a numeric code instead of a name, so they are easier to record. Costumes would be recorded in categories for 1 for horror, 2 for superhero, and so on. Sometimes these data sets can be hard to detect, so a good rule of thumb to tell if a histogram is appropriate to use is to try and group the categories into intervals using what the codes represent. Since the idea of horror is not necessarily less than the idea of superhero, putting them into an interval of horror to superhero doesn't make much sense even if the code is 1 to 2. A good thing to remember is that the pieces of data in a dataset for a histogram should be numerical quantities of something, and the categories we might break them down into should be ordinal qualities. Let's test your understanding of this principle now by determining which datasets in a group would work in a histogram.